This video explains how to implement Rockwell Automation's device libraries using Studio 5000 Application Code Manager. Use these methods to correctly configure device object add-on instructions and modules for use with HMI faceplates. I'll be demonstrating the use of some specific devices, but these steps generally apply to objects from all of our device libraries, including Power, I/O, Networks, Safety, I/O Link, and more. The instructions in this video assume that you are already familiar with the basics of Application Code Manager, or ACM, and already have a project created. Now let's get started. In this video, we will cover downloading device libraries, registering libraries with Application Code Manager, configuring device objects in ACM, using Excel and the Import-Export tool, and using ACM with FactoryTalk View. Feel free to jump ahead to a specific chapter. In case you haven't already done so, you can download any of these device libraries for free from the Download Center on RockwellAutomation.com. Just search for Device Library. Studio 5000 Application Code Manager is a free piece of software that can be used with these libraries to really speed up implementation. Think of it like an extension to Logix Designer that allows you to shift your mindset from traditional programming to bulk project configuration. If you don't have this yet, consider heading back to the Download Center on the Rockwell Automation website to download it for free. Before importing any new devices, the library needs to be registered. Find the setup command file in the root folder of the library files and run it. This will register all of the library objects with ACM automatically. Close the script window once it is complete. Now let's begin by opening up Studio 5000 Application Code Manager, or ACM. In this project, we already have some components pre-configured, including a controller, standard and safety tasks and programs, and HMI components including FactoryTalk View ME and SE servers and displays. In the right, you will see a Registered Libraries window, and here you should see any libraries which have already been registered. In the previous step, we ran the setup command script to register the device libraries, so here you can see an RA lib device folder containing all of the Rockwell Automation device library objects. To add a new device to a controller, right-click on the destination task or program and select Add New. The Object Configuration Wizard allows you to search of the library object that you need. For this first example, I am searching 755 to find a PowerFlex drive. You may need to check the box next to show all revisions in the event nothing is displayed. In most cases, you want to select the item with a library type of device. These usually have a naming convention starting with RAC, LD. Do not select the Asset Control Library type items at this step since they only include the asset definition, but not the ladder logic required to instantiate the device code. Now in the Object Configuration window, you will see a list of parameters that can be configured for the object. Not every device will have the same parameters here, and it's best to refer to the appropriate device library's reference manual for details about specific devices. That being said, a number of these parameters are pretty consistent across most devices. Start by entering a name and description in the top. The name will be the name of the add-on instruction or AOI instance. The description will be entered into the AOI tags description metadata field. Put something brief but helpful here because it will be seen in HMI components like the graphics symbols and faceplate window titles. I'll call this Pump 100 device for my intake pump VSD. Use the drop-down menus to select the task and program that you want to import this ladder routine into. Then jump down to the tag scope parameter. You can choose to create either program scope or controller scope tags depending on your preference. For some power device objects, there is also a parameter for object interface data type. If you have a plant PX5 system with a P controller, then this needs to be set to predefined data type with controller scope tags. And don't worry, all these parameters have descriptions at the bottom when you highlight them. Most devices also have module parameters. If the include hardware parameter is set to true, this wizard will automatically create and configure the device module in your controller I/O tree. Alternatively, if you already have your module set up, you can set that to false, but you will need to make sure the module is configured with the required device definition that's outlined in the device library reference manual. You will notice that a standard module name has been generated by adding mod as a prefix to the AOI tag name. You can change this if you want, but just make sure not to name the AOI and module the exact same, otherwise you will have issues later on. In this section, you can also define the IP address, the parent module, meaning the name of the Ethernet adapter, and any other hardware configuration specific to this device type. There may be other parameters to fill out that vary from one device to another. anything from extensions, sensor configurations, specific catalog numbers, or other details required to customize the import. In the HMI configuration area, you can define these parameters if you plan on using FactoryTalk View for your HMI and would like to generate pre-configured graphic symbols as faceplate launch buttons. Many devices have a couple options for symbol style, including either an icon, which is a graphical representation of the device to be used in system displays, or just a simple text button if you prefer. There are unique parameters depending on whether you are using FactoryTalk View SE or ME. In either case, you can browse the project to find the correct HMI server, and then on the right, go to the Displays tab and select the target display. You may want to organize this by area of use system, or just put all your devices on one display and then choose to copy and paste them to the correct HMI display later on. Now that all the parameters are completed, click the Linked Libraries tab. Just use the Auto Create button on the right to generate all of the other required items associated with the latter import. Then continue by clicking Next. Let's take a look at some other unique configurations across other library object types. Some devices like I/O modules do not have any instructions or controller code, so you can add them directly to your I/O configuration. Right-click on the backplane or Ethernet network to add a new I/O module. For remote I/O racks, start by adding the communications adapter. For example, this Flex 5000 adapter module. You just need to provide a chassis or module name and an IP address. There may be other optional parameters as well, like chassis size, RPI, or other options that are specific to your module type. Likewise, you can add in additional Ethernet communications modules to control Logic's chassis. To add more I/O modules to a local or remote chassis, right-click on the adapter or backplane and add new. The main configuration option on I/O modules are the channel descriptions. These will be displayed on the HMI faceplates and are stored in the module's extended tag properties. Again, you may have some options around HMI configuration and other module settings as needed. For analog modules with HART capabilities, you can directly add HART devices to the analog modules channels. In this case, right-click on the Ethernet adapter module and add new. Take special note that these devices are not added directly to the analog module, and this can be a bit confusing. HART devices can be configured with either a standard data connection type or a plant PX-specific type for DCS applications. The HART device is then linked to the correct I/O module and channel using the parent module and channel parameters. Bind the parent module by browsing for the instance of the analog HART module. After the HART device is created, you can also go back to the analog module and add in the reference to the HART device on the correct channel. This will allow you to pass individual sensor data to the HMI faceplate. When you are configuring an Ethernet device's parent module, the default setting is local, meaning the embedded Ethernet port. You will notice that there will always be a red X next to this parameter when it is set to local. There is actually nothing wrong with this configuration, and the X can be ignored. If you have another network adapter, you can directly browse for the module in your project, like this EN2TR module called Local 01. Some devices may also include a setting for parent module port, which can be modified from the default setting of 2 in situations where you are using compact Logix controllers in dual-port IP mode. Some devices, like this DCS object from the Safety Device Library, can allow bindings from parameters to I/O tags. In this case, you can browse the project for the channel bindings. In the left side of the reference window, find the instance of the I/O module that you want to bind. In this case, we are using a Safety Class Flex 5000 input module. After selecting the module, on the right side on the DI tab, select the correct channel, and then the appropriate sub-object reference, such as data or status. Similarly, some I/O link devices require linking to the master module, or you can link from the master module object to individual sensor objects to allow navigation between HMI faceplates. Once you have completed configuring your entire project, you can automatically generate the controller file. Just right-click on the controller and select Generate Controller. You will most likely want to check the box to create ACD, and you may want to overwrite an existing file if you have done this before. In the generated controller file, you can see that a number of routines have been created with the device add-on instructions and related code. These routines have all been linked to run from the main routine. The I/O configuration is also complete, including all of the device modules and even HART devices and I/O link devices. In most cases, your code should compile without any errors. It's that easy. If you have a lot of objects to configure that are very similar, you may consider speeding things up by using Excel to configure your project. You can start by exporting your current project. In the toolbar, navigate to Tools and select Import Export Manager. On the Export tab, select Complete Project and click Export and Open. Now say that I have 6 more pumps controlled by PowerFlex drives with similar configurations. I can simply copy and paste the rows, update the names, and assign unique IP addresses. I do the same for the associated linked libraries below. Save the file and head back to ACM. Now on the Import tab, you can select the import method that best suits you. In this case, I am choosing to merge with my current project and browse for the Excel file to import. The 6 new instances of the PowerFlex 755 are now created in my project. If you configure the HMI parameters on your objects and want to generate some pre-configured graphic symbols to open up HMI faceplates, you can also generate import files for FactoryTalk View Machine or Site Edition. Under HMI and Displays, right-click on the HMI server and select Generate Displays. You can choose either a single display or a batch import file for all displays. Another great time saver is to easily export all of the other HMI files and documentation related to objects used in your project. In the Class View window, right-click on the Controllers folder and select Extract Attached Files. In the extracted files, you can see a collection of relevant documentation, along with all of the FactoryTalk View files which are ready to be imported into your HMI project. You will also find files for Studio 5000 View Designer in case you are using that platform for HMI development instead. To set up a FactoryTalk View HMI project from your ACM project, first begin by importing all the relevant attachments that were extracted. You will need to unzip the images folders, then drag and drop them into FactoryTalk View. Then drag in the global objects and the displays. Then you can import the displays that you configured. Right-click on the Displays folder and select Import and Export. Choose the Import option, then you have options to back up any displays that might be modified. You can import either a single display file or batch import file depending on how you chose to export the files from ACM. Browse for the file and click Finish. Here you can see the display was created including all of the objects from the ACM project with each of the global object parameters linked and pre-configured. You can rearrange these on the display or copy them to other displays as needed. Here you can see that all of the graphic symbols on the display work properly without any modifications required. You should now have everything you need to get started with the device library objects, and they can be connected to any of Rockwell Automation's supported HMI platforms. Check out all of our device library videos for more information and tutorials, and download all of these libraries for free today from Rockwell Automation's Download Center at rockwellautomation.com.